Okay, welcome back everyone. So today we have China Team Selection Test 2021 1-3, which is you have a bunch of integers and there's like n choose 2 differences between integers, or not n choose 2 non-negative integers. And I want to show that there's at least some random number of things that can't be expressed as the difference of two things, or for like random expression. Alright, so n choose 2 is the number of differences. Can I just write n choose 2 here? N choose 2. I'll just say. So the heck? So actually the size of this set, or not just size, the number of elements here. Yeah, so sometimes specific numbers matter. You want to show that you can't get a different set that looks too similar to 1 through n choose 2. Why is there 619? Oh my god. Okay, so 19 is 1 mod 6. Yeah, I'm not sure that's it. I mean, let's sort the numbers, right? There is a use of 19. I wonder if you can. I don't even know if you can get that distribution of mod. If you take like mod a thing. Like for example, if you have n is let me just pick a random value of n for concreteness. Let's it's like n is like 8 or something. Like I have an idea that when you take a mod and you look at the well, actually, it's a little more complicated than that. Right, because the absolute value. Well, at least for mod, if you take mod 2, for example, you might already be able to get some parity read on it. So, like if I have n equals 8, then there's 28 differences, but they won't be equally. I don't think there's a way you can get 14 even differences and 14 odd differences. Is that correct? So can I get 14 even and 14 differences? Like, is that a thing that's possible, period? I want to say no, because the number of odd differences was the number of odd differences is given exactly by like the product of the number of evens times the number of odds. And you can't have 2 times 7 or something like that. Yeah. So right. More generally, for any n, Yeah, you'll get some missing things this way. I wish we could gamble. What do you want to gamble on? Because I think it's possible. I think I can set up a thing where you gamble on something, but I have to figure out how you do it. And I would also have to figure out something to bet on. You can bet on problem proposers for nice. That seems like people who run nice just profit a lot. Yeah, that seems a little questionable. Gotta say. Alright, yeah, so if I do this, I can get at least... What is with 19? Jesus. What is n choose 2? N choose 2 is just the number of differences. I think that's fine, right? Like, the number of differences of AI minus AJ between, like, a large... where J is greater than I. Yeah. I don't think specific values of n are going to help, though, given... Like, given this bound, I'm... Like, given the bound is this, like, I don't think there's any... I don't think this is the true bound, so I don't... I feel like there's like some proof that will work and it's just not tight and gives some random ass bound like this. And so looking at small cases, I don't think... Yeah, like for example, when n is like less than 6, for example, you just get garbage, right? Is this the first problem? Yes. What do you do with the freaking 19? Actually, okay, I want to push this line of thought a little, actually. For n equals 8, 14, the... Oh, you can get 15 and 13, so it's actually pretty close. Is it closer or larger? Is it that close or larger? Yeah. No, it won't. This will only get like O of n return. So I don't think I can push this method to get something quadratic in n. What am I worried? You want to try to get like some number of... Wait, someone figured out the solution in chat? Wait, what? Have I been completely not watching chat or something? Wait, what did I miss? What? I'm very confused. Well, I was just thinking like to show like I can at least prove that the difference set is not given exactly by I'm just writing some random stuff. Like I'm trying to show that there's at least one number that's not representable, which doesn't help. Yeah. In general, I wonder if I can like say something about mod, but the error terms you get there will always be out. No, I don't think parity will work. The ceiling doesn't do anything. Okay, the ceiling is just there because like the number of unrepresentable things is an integer. So you can ignore the ceiling. You just want to prove it's at least this thing. The ceiling doesn't matter. N equals 5 even I think even n equals 5. Yeah. No, yeah. What does the thing inside represent in terms of combo? If you can find a representation for n times n by 6 over 19, I would love to hear it. Actually, what's promised for? Okay, so actually, oh god. N choose 7 over n choose 5. You want to look at the generating function? I mean, the I don't like it. I don't see a reason to. Like, what would I do if I had that? Okay, the other thing I really should be doing is I should be saying like we're looking for collisions, right? So a minus b equals c plus d, c minus d. You get a collision whenever a plus d equals b plus c. And oh yeah, overflow issue is more important. You're right. Okay. That sucks. Yeah, so somehow I need to use something about the size of the numbers. Like I can't let the if I just let like the numbers be crap. I wonder if I should be looking at the gaps or something. Like rather than You let d1, d2 be the differences between them, and then you're looking at like partial sums of the di. And it's like, how big can that get? Also, I remember something. Perfect golem rulers. Yeah, degenerate was one. Meant to be close. What role does big N play? Oh, sorry, that should be lowercase n. Do we do n equals 7? Do you want to do n equals 7? Okay, for 7, there's like 21 differences. You need to, in order to have a perfect ruler, like if you want to get every difference, then you need to have 11 odd numbers, which is not possible because 11 is not the product of two numbers which sum to 7. But as I said, like, yeah, I'm convinced that small cases are not helpful for this problem. I think there is some solution, and that solution gets this bound, and that bound is not tight for any n. So small cases, this is not column though, is it not? Like for small n, like, wait, is this not? Wait, what did I miss? At least for small n, I think for small n it's like a perfect column ruler or something. And then like it's basically what happens is the theory of perfect column rulers says that for n at least 5, for 5 or more marks, you cannot get like every integer. Everyone wants to figure out. Well, I mean, if someone has a suggestion for what 19 means, I'd love to hear it, but I don't see it. 19 is... (16 plus square root 16 minus 1). No, 19 is not 6 choose 2 minus 2. What? Minus 6. Why are people writing all these wrong expressions for 19? Okay. Okay, fam, I have a question. What happens when I take mod 19? This shouldn't work because... I mean, it shouldn't work because... Yeah, no. You need something about the size of the numbers. Because you can get... Well, actually... Take mod 19. 6E. Wait, really? No, I don't believe you. E is like 2.718, right? So 6E is like 16.30. Yeah, I think the constants are garbage. Like there's, I don't think this bound is sharp. 7E. Unfortunately, because the bound isn't sharp, there's no footholds. Oh, come on, kids. N times n minus 6. Okay, what am I missing? Let's see. I'm just like not able to think of shapes of solutions that will do. I should be trying more things right now, honestly. I'm just kind of staring at it. Work modulo and choose 2. I don't think so. The reason that none of the mod arguments can work is that I think you should be able to get most of the residues modulo any... Like you can get it basic... If I fix any small number p, you can get it roughly equally distributed mod p. And because of that, you will never get a bound that is quadratic in n. You'll at best get a bound that's like linear in n. And honestly, it's probably like O of p. Or something like that. Mod n choose 2 is maybe a little more promising just because that margin is large relative to n, but I still suspect that... No, actually, I don't think that should work. Like, for... Yeah, I don't think you'll get a bound that's good enough by taking a mod. No, I believe. I just don't think the mod argument is going. Do I? I feel like it shouldn't work. I can't prove it the same way I can prove it for like a fixed prime, but my feeling is that you can. Yeah. And then minus 6 over 19. What is 19 doing? 6. Why not 6? Yeah, like I was saying earlier that I was kind of wanted to take the consecutive differences. So you instead have d1, d2 up to dn minus 1, and then you can add up any contiguous substring. But you make an only problem like this that uses e to the pi, I will quit. Wait, all you need is like you have like 23 to the I, you know? Ask someone to estimate 23 to the I and see if they realize that 23 is like about e to the pi. Great idea. Nineteen. Yeah, I have no idea. What the heck do you do with this? It's been said it in chat a few times already. Wait, actually, generating functions is correct? Wait, I like didn't believe that that could work. Are you what? The heck? Wait, what? Okay, so I take the generating function and so I guess you have to consider x inverse. That's fine. Sorry, what am I writing? X to the an. Okay, so you turn to sum inverse and x to the an minus x to the an minus aj. And I want the number of distinct monomials. Frick. Okay, so no, like this is the like the problem is how do you get information about how many times a thing appears? Like I just don't see where you get the power from. Like where when you do this. Like one, how do you bound the exponent? And two, could you now subtract x be an n choose 2 root of unity? But the thing is, if you let x be an n choose 2 root of unity, you're basically taking mod n choose 2, so you won't get any new information you didn't already. I mean, okay, so fine. I will subtract off the sum from k equals minus n choose 2. Is mod n choose 2 literally enough? I don't believe that. Right, okay. Like, what do you do with this? So, okay, so when you subtract off, n squared minus n plus 1th root. Alright, The frick? Okay, so specialize that would be a primitive n root of unity. So okay, so now f of omega inverse is equal to like, and I want to bound this from below. Okay, so every coefficient that's left over, there's like sum of ck omega to the k, and I want a lower bound on the sum of ck. So in order to do that, they don't even point the same. The frick? I feel like I'm being dragged through the generating functions, kicking and screaming, because I just don't believe that I can do anything. What the heck? No, but I want a lower bound, right? Oh yeah, wait, yeah, also the signs are mixed. Yeah, no, like I don't see how this can possibly do anything or something. Like, what am I missing? Do I like filter or something? Like, I could sum over all the roots, but I want to bound on the sum of the negative things or something like that. What do I know about this thing? I know this thing is. I don't know anything about this. ck equals c minus k. Wait, no, like what's this? How do you get information out of this? try to relate to the... What is the problem asking? The problem is asking that like the n minus 6 over 19 thing. No, I don't get it. Like, you have this random ass expression where I guess it's symmetric, fine, but you have some negative coefficients corresponding to things that you missed. Actually, that's all. You might have some positive coefficients corresponding to things you got, but you don't care. You care about the negative coefficients where k has absolute value at most n choose 2. And how do I extract that? Total negative and total positive. Yeah, that's fair. Yeah. So I just want the sum of... Yeah. Right, okay, you only get negative ones because of this. So you want to add the number of negative ones to the number of, like, whatever other junk you get. Alright, so there's a bunch of junk. Okay. Also, can I say anything about this? This is some... adding thingies. I don't... Yeah, okay. Alright, okay. We can use the fact that... some KCK. But like... Also, there's like a minus n or something because we subtracted a lot of... Okay, this thing has a lot of n's in it. So there's like an n minus 1 and then like ck for k greater than 0 of... like, fine. But do I say something like... The constant is n minus 1, I agree. Right. These ANs can be as big as they want. So I can't read any size information from here. Because you could have... This could be as large as n squared, or it could be as small as it wants. These are minus 1. For the k that I care about, k is less than like n choose 2 or something. So... maybe the sign will work out. So this is like, let's see. Right, if omega is a 7th root of unity, but k is... I only care about the negative contributions from n choose 2 or so. Like x minus x cubed over 6. Thank you, Province NT5, for the follow. Oh my god, what a disaster. Hang on, if I have a 7th root of unity for, I think it was 3, so that means k can be up to 3. No, that can be, the signs just flip. Oh, freaking god. Hi, oh great Evan Shen. Hi. Don't need that many honorifics. Kachi Davenport. I think we ruled out mod P a long time ago. But apparently now we're taking mod n squared minus n plus 1. And I'm... Oh, Jesus Christ. Yeah, no, it's like the cosine, right? But it can still be negative. Like, I was thinking, oh, maybe the signs are all positive. But that doesn't help. Like, you know, this could be any of them. Why is the constant term n minus 1? Well, I wrote n minus 1 because, like, this thing generates, like, n ones. And then you subtract a single one off from here. There's also some other junk caused by, like, you know, technically k is greater than n choose 2. But... Alright, let me just read this. What is this garbage? No. This can't work. What? How does this possibly work? Oh, right, sorry, I forgot to subtract. Let me... well, let's just put an omega. It's smoother that way. Oh, frick. Fuck. Tech. So yeah, the point is that this sum is equal to 0. Well, actually no. Well, let me write it with x first and then substitute in omega. I also have no idea what this has to do with 19. $19 is greater than 3 pi. True statement. Also true with 6 pi. I mean, it's looking like that. No, what are you talking? The pi is 3.14, so 18.84. I'm so lost. Wait, I mean, we haven't done anything yet. We've been told that this is what you're supposed to do, and all of us are staring at it being like, how is this supposed to help? So some CKs are -1, the others are +1 or more. And I would like to... Yeah. Either bound the sum of the positive CKs or bound the sum of the negative CKs, or count the number of CKs which are -1. Then use sign to bound it. I don't... Or we could bound the sum of the absolute values of the CK. Actually, that is fair. If you bound the sum of absolute value of CK, that's also okay. But you want to bound it from below. Below actually makes sense. So I don't know. You guys want to use this sign? Is this K? We picked an n squared minus n plus first root of unity, right? This is the dumbest thing I've seen all day. All right. So here, this guy, this loser here. This can be as large as n. Okay, well, so much for that. How small can it be? It can be pretty small, right? I think it's very appropriate. The song right now is called "No One Believes Me." That's exactly how I feel right now. Should I be? Oh shit! Yeah, cosine with a factor of 2. Yeah, I think it should also. I also agree it should be about as small as. So left hand side is actually given exactly by the absolute value of f of omega all squared. I don't see any reason why that should be bounded away from 0. I guess we want it to not be around n minus 1, which sucks. Like, why? The other thing is we can try to. Can I like integrate around the unit circle or something? Yeah. I don't know if it's far from root n minus 1. It can't be too small? Why not? Why can't f of omega just be like a very small complex number? Because these things are all pointing whatever direction, whatever heck direction they want, right? It's the sum of n vectors. The vectors all have unit norm, but they point in like random ass directions. I don't see any reason why this should be bounded away from 0 or root n minus. Oh jeez. they're just like. Because your sum is actually almost n minus 1. Which sum? No, this is squared, right? I didn't drop a square root or something, right? Like this is pretty. But I don't see any reason why this thing can't be about square root n minus 1. I definitely said random-esque. I don't know which. The other terms cancel out. I don't understand. Are you saying the right hand side is small? I mean, that's what we're trying to prove. Or sorry, trying to avoid or something like that. The other thing is, it's possible that I should be like sampling over. We want a lower bound on CK because the number of omitted terms is equal to. So all the CKs are either positive or negative 1. The sum of the CKs is 0 by hypothesis. And the number of negative 1s is given exactly by the number of missed things. So we would like to show that the either there are. Why can't one of them be minus 2? How would it be minus 2? Yeah, like you have all positive cove. Why not? It could be plus 2. I said they're either positive or negative 1. Oh, sorry. Either positive, comma, or negative 1. Sorry, that's what I meant. Either a positive number or is exactly minus 1. Let me rephrase that. Yeah, that is confusing. If I meant plus 1 or minus 1, I'd say plus minus 1. Yeah, so you can either get me the number of negative CKs. CK can be 0. Yeah, it doesn't have to be. Yeah, sorry, CK can also be 0. I was only thinking about the positive terms. But yeah, you can either get me the number of negative CKs, the number of CKs that are equal to minus 1, or the sum of all the CKs, or probably most relevantly, the sum of the absolute value of the CKs is probably the best metric. Do I like take a random. Can I take a random root of unity? Like a random primitive root? Because the absolute value. The absolute value will change if I change which root I take, right? And I don't really care about this because I'm gonna bound cosine by 1 is the plan. So is it the case that if I randomly sample across the roots of unity, then this thing will not be too large? This is called... Yeah, this is called desperation. Oh, well, yeah, it only gives you the constant term. Yeah, no, I don't... Yeah, I don't... How is this supposed to... If too many CKs are 0, then the sum is close to n-1, I agree, but this difference is O of n squared. Why is the difference O of n squared? Differentiation. Substitute x equals 1. If you get substitute x equals 1, you get 0 equals 0. Like, you won't get... because there's no information here, when you substitute x equals 1, you won't get any information after either. Why is the difference O of n squared? No, the sum of CKs will get... Okay, here. Let me write this down because people keep asking. Yeah. Every CK... so CK is at least -1 for all K. Number of missed differences is exactly the number of CK, which are -1. And finally, sum of CK is equal to 0. I want a... Oh, sorry. Absolute value. Yeah. So, I want a lower bound on CK. Yeah, basically you have a bunch of things that are -1. And some positive things. How do you count this? I don't know. Like, I was convinced that generating functions couldn't possibly work because I don't see, like, why this would... I wasn't even convinced it would work in this form, and then I was told to plug in a root of unity. I don't get it. Try to do comma normally. Yeah, it's just Fourier analysis. The heck? I don't think cosine helps. I just wrote it. Wait, I'm so confused. Something with... This thing is n-1 plus... Something with absolute value at most. Okay, so for every missing thing... Okay. Well, let's call number t, alright? Right, so we agree this is n-1 plus something which is less than or equal to 4t. Then the 4t is O and n squared. What am I not? I don't get it. What am I doing with my life? What is this? Why is, what? Why is it O of n squared? I just don't see why f of omega is, that's... Oh, so did we take the wrong primitive root? Is that what's going on? I don't want and choose 2 through to reading. I want something smaller. Why is this at most 4t? Well, it's like... I mean, you can say this is less than or equal to n plus 1 plus twice the sum of absolute value of ck. And that's actually exactly equal to 4t. Did we take the wrong root? Someone said n squared plus n minus 1 was the correct root earlier. God damn it. If I take this to be... Wait, but then this is... That doesn't help me. If you take x close to 1, it won't do anything. You need to take a... Like, the whole point of this approach was that this sum was supposed to vanish, right? I think it might be 80. Am I off by a really big factor of... Wait, is it 80? I thought it was 40. T is the number of missed differences. It's the thing we're trying to show is at least n squared-ish. Yeah, but I just, like, the whole... Yeah, this, you can use any root. Yeah, like the problem is you don't have any control over this, right? Like this method can't work unless you can say something about this. Any root other than 1. So you want the largest possible value of f omega across... Well, the thing is, okay, so are we picking like a random root of unity? I said this earlier, the for it doesn't work. Yeah, I mean, well, I made a bound, right? Yeah, it doesn't, I mean, once I write this inequality and throw away the cosine, it doesn't depend on omega anymore. Use the second line, add back the sum x to the k? This thing? Don't use ck, use ck plus 1. I don't... What? I must be insane. Like, you can't take the same identity and squeeze 2 different statements out of it, right? Like, that's... Yeah, you want absolute value f to be, yeah. Yeah, you just want you want omega to be such that absolute thing is big. Alright, okay, so I mean this is the same identity. Dude, I'm not I'm not that optimistic that you can force it to be large. Maybe you can, I don't know. I don't know anything anymore, okay. This is my commentary. Expected. Well, the problem is you need the absolute value, because if you take the actual expected value of FW, it's literally like just a constant term. Or 0. Or something. I don't know anything anymore. How is this supposed to give us a lower bound? When I plug in omega, these things are not non-negative, right? Like these can have any sign. This is not negative, but this is not necessarily non-negative. Expected value of f of absolute value. But you can pick a root such that... No, there's no reason you can pick a primitive... there's no reason you're promised there's a primitive omega that makes them all line up. Like, imagine, like, if... Actually, there's a lot of numbers, but, like, you can have them all just be, like, approximately diametrically opposite, right? Like, you can't literally have it diametrically opposite because n squared minus n plus 1 is not even, but you can have it, like, basically diametrically opposite. And because of that, the growth rate will be... Why does it need to be primitive? It doesn't need to be primitive, but... We only need greater than n plus square root n of them to line up. Very basic. No, like, yeah. But like, suppose like n equals 8 or something, right? And so you have like these 57, okay, what the hell is this? 3 pi I over n squared. Wait, how the heck? Oh, okay, let's look up Parseval's formula. Okay, Warren says we should pick a... Warren even says we should pick a specific root. He says pick e to the 3 pi I over n squared minus n plus 1. How? That's not n squared, so the sum is non-zero. I don't get it. Then the sum can be used and it's pretty large. What? Wait, what are you doing with the a sub n's? I don't see how you can get a lower bound like this. Also, where does 19 come from? This still doesn't explain why there's a 19 and then minus 6. Is it like the 3 pi or something, and like 6 is twice the 3, and the 6 pi is the 19 or something? Okay, f omega minus is at least 1 over sine... What is sine w? Problem request. Problem requests are a bit late at this point. We've already started. Let me look at the question though. Yeah, probably enough there. I must be insane. So the sum of the omega to the k... Wait, no, this doesn't make sense. You're plugging in omega is e to 3 pi I over n squared minus n plus 1 into this thing. This sum doesn't matter, it just disappears or whatever. And these are non-negative. That's fine, whatever. But how do you get a bound? At least, why is it at least 1 over sine... Okay, I don't know what's going on in my life anymore. Okay, so Parseval says that the sum across the primitive omega or something, or is it the sum of all omega? Wait, I just don't see why that inequality root is true. Why is... Like, where are you getting 1 over sine from? F omega... Like... How are you getting a right-hand side that has no ANs in it? I guess is what I'm trying to figure out. Do we have the same definition of F? No, like, I know what you're saying, the sign of that angle, but I don't see why. Like, where did all the ANs go? That's the question. Like, how are you dealing with all the A sub n's? FW... So where's all the A sub n's? 1 over sine... Yeah, so, but... where does f come from? Like, where are you using anything about the function f? Also, what is Parseval's theorem? Well, okay, I actually should just be able to work it out. I'm just using the second line. Also, what does Parseval give? So it should be... If I do the... What does Parseval give? I don't actually know. Left-hand side is my accent is the Fourier transform thing. What's a Fourier transform? I don't remember. Uh, the coefficients are n1s and a bunch of zeros. Okay. Wait, actually, wait, this is really, this doesn't look right. This is too big. The average, oh, actually, no. You're averaging. So is there, does this promise there's an omega for which this is n? That feels like too good. That gets like n squared over 4 as a bound, if this is really the case. Okay, that's fair. There's an omega. So if I take out the one, okay, that's true. This includes all. Okay, so that increases the average by 1, right? Though. So the average of all the other ones is something. Wait, does this give us this? This just actually gives us quadratic bound, actually, right? Oh no, it's square. Oh, never mind. Sorry, I'm off by a square factor. How do I prove the Twitch lemma? You should look at a maximal cycle that is not Hamiltonian. Naman keeps saying that Warren is doing the right thing, but I don't see it. That was a typo. Oh my god. I don't get it. I don't get it. What is going on? N minus 1 is at least f of like Wait, I just don't. How do you get that bound? Where is the 1 over sine? What? What? This thing. This is at least f omega squared, which is also equal to this thing, which is apparently this thing, and then you bound this below. Okay, wait. So you're saying that also f of omega inverse is promised to equal n plus the sum of k of ck plus 1. So without the... Okay, wait, so... No, what? No, wait. I mean, the 3 pi is equal to 19. Have you considered doing a stream with easy problems? I do whatever problems people throw at me, which may or may not be easy. So some days I get a lot of easy problems, and then there's days like this where I get abominations like this problem that I probably am not solving anyways. So it's one of those days. If you want easy problems, you should request easy problems at the start of the stream. So problem requests come in like for the first like 5 or 10 minutes each stream. Well, Oren's claiming that he's done, and I just don't see it. I also don't see what the 3... Why is there a 3 pi, actually? What does the 3 do? Oh my god, no. We're not doing Lagrange multipliers. We're not doing Lagrange multipliers. 3... Just delete the square. I don't get it. The fuck? What? Do you set omega equals... (3 pi I over n squared minus n plus 1. And then... What do you mean delete the square? Like... These things are not promised non-negative, right? Either this expression or this expression. There's no non-negative promise on the rest of the terms. Right? Or what? The sum x to the k... I didn't do the plus 1. Which... The third line is not quite true. With this thing? N squared... Omega isn't a root of... Oh! Omega is not... Oh, I'm so stupid. I see. Okay, I understand. This is not a root of negative 1. Okay, fine. But... Okay, so when I plug in that omega... now... Wait. Okay, so you are not picking a primitive root. You're picking omega is 3 pi I over... It's not 2 pi. Okay, so this is false. Then when I pick that omega, this thing is... What is it? Is it minus 1? It doesn't really matter. So this is almost a primitive root. This is in fact the square root of a primitive root or something like that. Okay, so when that happens... Okay, so this is x to the n squared minus n plus 1 minus 1 over x minus 1-ish. I don't know. Wait, this is ridiculous. How? Okay, so the point is this is... Yeah, I'm so sorry. I thought the whole time you were plugging in a primitive root, and I was like, how the heck is that going to do anything? But you're not plugging in a primitive root. You're plugging in 1 over minus 1 over omega minus 1 times like this is like omega to the... God. Thingy. Something. Okay, this is omega to the something. Okay, this will work. This will work. Oh god damn it. So this is f omega squared plus or minus omega. Oh, basically you plug in something that's not a root and this thing becomes huge and this eclipses everything else. Yeah, you plug in that. Okay, so now, this thing's at most n squared. I don't even care about that. So, 4t is greater than or equal to, yes, I'm using Vim. Like, so the giant thing is like sine of 3 pi over n squared minus n plus 1 ish. Like, minus like, maybe up to n squared and minus n minus 1. No, hang on, I don't want this n squared here. How do I bound this thing? Can I prevent this thing from being too big? This does not work. Well, you're subtracting it, but the numerator is like... Okay, hang on, let me get this right. So, god damn it. Okay, sorry, you are correct. I actually care a little bit about this sign. Okay, I actually care a lot. Okay, so this is omega to the, let's compute this explicitly. So we're gonna omega to the minus n choose 2 times omega to the 2n choose 2 plus 1, so n squared minus n plus 1 minus 1 omega minus 1. Okay, and this is an absolute value, so we'll actually just write it. Alright, that's actually better. I'm not supposed to absolute value everything. So 4t is at least that. This is actually a real number, right? Okay, so this is minus 1, so this is minus 2. So omega minus 1. So this is equal to 2 over 1 minus omega times omega to the minus n choose 2. Minus n minus 1. And... oh god, please work. I guess that's basically this. I flipped the sign. Which sign did I flip? It's missing a minus sign. Which minus sign? This thing is negative 1, right? I forgot the original sign that was originally on the sum. Okay, so minus omega to the n choose 2 is Alright, so this is close to... Yeah, this is like basically 1. This will be basically... I don't know, something. Okay, so you bound it or something. When it's funny because when you write it this way, it doesn't look like a real number, but it is, right? When I conjugate it, it's exactly a real number. So in the trig functions explicitly, what does this equal? You don't think this works? Is it 1 over... I actually just don't know what it equals. Wait, is it actually exactly 1 over sine, or is that just the estimate? I can't tell by looking. I think it's really negative. Really? It's negative? This is a minus. I didn't fix the minus sign here. I need to fix that, sorry. Well, no, you care about the sign because, like, if this left-hand side is negative, you just die. Like, nothing you do will save that. This is definitely promised to be a real number. It's the sum of a bunch of cosines. If I do 3 pi I... I think that's maybe why you do 3 pi I, right? Or not? So, do I have a sign error? Is this the correct function? You should properly work out this sum. I mean, this is what it's exactly equal to, right? Because it's a geometric series. And... I mean, so going from here to here is fine. I'm not worried about that part. I'm worried about the part where we claim this is like 1 over sine because I have no idea what it equals. Oh, actually, okay. Okay. The way, sorry, I am stupid. What you're supposed to do is you just put the omega onto the bottom. So this is like, 2 over. Alright, let's get this right. Omega to the n choose 2 plus 1 minus omega to the n choose 2. Or something like that. It's symmetric forms of the geometric series. Like as clear as omega minus omega inverse. Yeah. I mean, probably. But I'm already here because I messed everything up too many times. Wait, so where does the I come from? Like, if I think it's a sign, there should be like an I thing somewhere, right? But I don't see it. Alright. Let's close this out. Where's the I? Like this doesn't look right to me. This thing resolved to -2. 2. No, that sign should cancel here, so there shouldn't be. Oh my god. How do you do calculations? Please help. I still don't understand. I don't understand either. Yeah, this is n choose 2 minus plus 1. So this is omega to the n choose 2 plus 1 over no, choosing the conjugate won't change anything. Like, because here, when you look at this thing, this is the sum of cosines. So if you take the complex conjugate, this doesn't matter. I think the problem is that this thing is a primitive 2n squared minus 2n plus first plus 2 through to unity. Okay, so this is the secant. Wow, when's the last time I got to use the secant function? Of n choose 2 over n squared minus n plus 1 times 3 pi. Oh, this is a disaster. Minus n minus 1. Okay, did I make it? Is this calculation right now? This is like the... Okay, so can someone Wolfram Alpha this and make sure I'm not insane? Because I feel right now, I think right now I'm insane. At least this problem is driving me insane. Small. The problem is that we were taking the wrong route. Like this is a primitive. The mistake is we kept picking an n squared minus n plus first root of unity, and Warren kept trying to tell us to not do this, and I didn't realize what was happening. Like he kept writing the 3, and it didn't occur to me that like 3 is odd. No, but you can't fix it by conjugating. The reason you can't fix it by conjugating is if you take the conjugate, this is a cosine thing, so it won't change absolute value. Okay, let's keep going. Alright, so... so this is 1 over... We'd like to change this to sine. So cosine is... Okay, sine of pi over 2... God damn it. I can't believe I spent 2 hours of my life on this calculation. Why I could drop the f of omega term. This thing? This is non-negative. That's the key. The point is, if this is positive, so this is non-negative. This is absolute value. You're subtracting a positive number. No, I don't. I think the point is that this is supposed. Am I crazy? No, it's the sum of two positive things, right? Or did we pick the wrong root? It's definitely positive minus positive. Well, crap. That's not good news. Really? Also, it's cosecant. No, I think it's secant. This is a cosine on the bottom here, right? Cosecant is 1 over sine. Yeah. Wolfram Alpha says cosecant. The frick? With this thing? No, but I wrote it this way. How is that not a cosine on the bottom? No, I think it's this, right? I mean, now it's like I subtracted a half pi. That's why this fraction looks so screwed up. Oh my god. What a freaking nightmare. Why am I doing this problem? That is a lot of Fourier analysis. No, this is not Fourier analysis. This is just called, like, bashing the frick out of the stupid... Wait, so did I make a mistake from here to here? What did I screw up? Like... So omega to the n squared minus n plus 1 is minus 1. This is the geometric series. It goes here, here. Omega to the n minus n choose 2. So, here 2 over... Okay, so it's equal to this, because this numerator is minus 1, minus 2, so this is 2. So, I multiplied on, like I promised. N choose 2 plus 1. This is 1 over n choose 2, so it's the secant of this thing. Right? Yeah, okay, jeez. You guys make me think that I'm losing my sanity or something. Okay, so this is sine. Actually, this is sine of about 3 halves pi squares. This is like about 270 degrees-ish. So that's not great. Sine of 270 is... No, what I can do is I can negate it. No, this is fine, right? It's sine of negative 270, which is sine of plus 90, which is big. Wait, hang on. Sine of 90 is close to 1. We want it close to 0. Shit. No, hey, no. This was pi is 180, right? So this is about 1/2 of. Am I just? This is so stupid. What am I doing with my life? Oh my god. Oh, sorry. I'm bad at adding fractions. Sorry. I don't know how fractions work. This is n squared minus n plus 1. There, much better. Alright. Okay, we're back in business, everyone! Alright, so... minus 2n squared! Minus... plus 2n. Hang on. Okay, this is not looking good. So we had this thing. I took a secant is pi secant. Hang on. This is about 1/2. This is secant of 270. Cosine goes then. Why can't I get this trick to work out? Holy crap! No. Answer minus n plus 1 minus. So this is minus 2n squared plus 2n. Where did the 3 go? Wait, we lost the 3. That's the 3 that's supposed to give us the, like, 6 pi is about 19. Right? Yeah, we lost the 3. What the heck? Wait, okay. This last line is wrong, right? I definitely made a mistake here, because that 3 is really important. We can't lose the 3. So... There is a plus 1. There is? Where's the plus 1 from? Oh, that plus 1. Yeah, okay, I agree. There is a plus 1. Okay. So this equals... Okay, so I want to... minus pi. So we subtract 2n. Hang on. So, okay, so 3 minus 1. Yeah. Okay, so it's sine of something that's... Wait, okay, isn't this negative? Did I flip the sign again? No. No. So when you change a sign by pi, it flips sign. So why what went wrong? Why can't I get the sign to work out? I'm so angry right now. There was sign flipped on left page last line. What? Where? Here? I flipped the sign from here to here? No, I don't believe you. What? Disaster. Wait, so you're telling me from here to here I flipped a sign? Everything else looks right. Well, what? How is this not equal to this? Like, hello? Is this supposed to be entries 2 plus 1 or something? Did I don't know. Okay, this is a geometric series. Minus. Starts from minus entries 2. This top is minus 1, so this is 2. I put the entries 2 on the bottom. It's... Oh, crap! No. Yeah, okay, I flipped this line. You are correct. This should be omega minus 1. Because I got rid of the... Okay, so this is negated. So these are all plus 1. So this is I choose 2 plus 1. So this is 3n squared minus 3n minus 3. Yeah, minus 3. No. Crap. Hang on. 3n and minus 1 plus 2. So this is minus plus 6? What the freaking... Okay, you know what? We're not going that route. We flip this sign. We'll make it a sign flip. Okay, wait. So this 2 is this. Crap. No, revert. Go back to what it was before. Oh, shoot. Oh, I screwed up. Oh, crap. Okay, hang on. So, n choose 2 plus 1, right? Or whatever. This is fine. This is plus 2. So, n squared minus n plus 1 minus... Okay, so now I have a freaking, like, plus 5? 1, this is minus 5. No, now the signs are all wrong. Actually, no, this is fine. minus 5. Okay, good. And now there's like minus 3 here instead. Or something like that. Yeah, okay, great. And now I can get rid of both of these. So now it's this thing. And sine of x is at least x. So, I want to lower bound this, right? Sine of x. Oh, sorry. Sine of x is the most x. God freaking. Okay, great. So it works the way. And on the bottom, we have the wonderful 3 pi that we've been looking for. Yeah! Yeah! Oh, wait. I didn't mean to do that. Minus n minus 1. Which is at least... Why is my bound off by a factor of 2? Wait, oh, what? No! This was supposed to work, dang it! Oh, wait, 3 pi... I'm sorry. 3 pi is... Oh my god. 19 halves. So, 4n squared minus 4n plus 4 minus n minus 1, which is at least 4n squared minus 23n plus 23. And when you divide by 4, we made it! We made it! We made it! Alright, who wants to... I can't run consecutive ad breaks, but I'll write up the problem now. Now that we've gone through all that very hard work. And, I don't know... I'm so confused right now. China TST 2021-13. All right. Crap. Oh, I think the last hour was just me like struggling really hard to compute trig functions. Okay, so the idea. Okay, now this is what write is for. Now we can do the recap. So the idea is to consider the generating function f of x equals sum of I x to the ai. Then we may write. So sum f of x times f of x inverse minus the sum from minus, I'm gonna let n equals n choose 2 for brevity. Minus n x to the k n equals, so when we write this thing is equal to the sum of like some okay, so this thing for some constant ck, it is easy to see that if t, so every ck is at least -1, and ck equals -1 exactly if k is missed, and sum of ck equals 0. So if t is the number of missed things, then the sum of the absolute values of ck is exactly 2t, or sorry, yeah, 2t, 4t, sorry. Sorry, 2t, then sum is, and we want t at least like the ceiling of n minus 6 over 19. Well, okay, we now specialize to the choice x equals e to the 3 pi I over n squared minus n plus 1. On the one hand, the left-hand side is at most, actually I should do k greater than 0. N minus 1 plus, left-hand side is at most n minus 1 plus 4t, because ck because omega by the triangle inequality. And on the other hand, moreover, also absolute value of f of omega all squared plus the sum of minus n to the n x to the omega, or sorry, omega to the k. This is a real number because the expression is self-conjugate. We drop the first term because it is non-negative. And evaluate the second sum. Exactly. And then I paste this wonderful calculation that I did. Okay, so let's take out the frames. Can you move my head over? Oh, yeah. Okay, so which things don't I need? Sum of minus n to the is given exactly by minus, okay, so oh yeah, all the n plus 1. Okay, so this is equal to 1. Okay, so 2 over okay, so I can fit that on one line. Come on. I think I can take out that paren. Don't need that one. Don't need that paren either. Okay. Okay. So this is 3 pi, and then this is okay, so hence it follows that so 4t is at least this thing minus n minus 1 and this is greater than or equal to 4n squared minus 24n over 19. The problem is solved. I don't know either. Like I feel like I feel like some black magic just kind of happened, and I got nothing, man. This is too. I'm amazed. This can be one line, honestly. What's the tightest bound? No idea. I don't think... Yeah, you probably don't want to know. Yeah, I guess the idea is you pick a value of x such that this thing is a huge positive number, I think. I think 3 pi I... Why do I pick 3 pi instead of... What happens if I like pick pi I instead of 3 pi? Oh no, the sign will be wrong, I guess. Yeah. Alright, this is a solution. We did it. So if you pick 1, I think it'll be a big negative number instead of a big positive number. And if you pick anything bigger than 3, the bound will be weaker, right? Because the denominator we saw was 6 pi. Yeah, it's definitely written backwards. Like this form is too artificial. I still can't believe that method can generate a result. Is weather the actual weather? Yeah, this is the current weather in Boston, which... Holy crap, why is it so warm? Okay. Alright. Oh, come on. Frick. I hate this search. Frick. It should be this blank. Someone have a link? Oh, great, thanks. H249183. Oh crap. This is 2002 TST as well. Oh no. Well, this is a perfect golem ruler. This is different. Okay. Many hours of pain and suffering. Oh, I think I tried to hide tags because I thought it would save some screen space, but apparently it doesn't. Hours of pain and suffering. Oh, sure. 6 pi is less than 19. You know, I didn't need to let n equals n choose 2 for brevity because I wrote it out everywhere. Freaking. Thank you, Warren. If you're still here. I totally just did not understand what you were saying the whole time. I was just like, I'm sorry, I can't figure out. But, yeah. You are right. This is the right choice. Just post China. Ha! Oh, that's funny. There's another user called Just Post Taiwan TST as well. Yeah, Warren would do what he was doing the whole time. The whole time I was just like, how can the thing you're saying possibly work? And then it works. So, yeah, shout out to Warren. MVP. Alright. We're done with that. Okay, so quite a few things. So first of all, shout out to mental breakdowns from this problem from Space Sam. Actually, yeah, that's the only shout out. The 3 pi. Yeah. No, the 3 pi. I think if you try pi instead of 3 pi, the number won't be positive. Like, I think you'll probably either end up with like a big negative number or something like that. You can try it, like if you replace every 3 with 1 in the proof. My suspicion is that, well, the final expression ended up being this thing, right? And, well, actually, now that I think about it, why do we need 3? If I replace every 3 with a 1, does anything go wrong? This constant will be different, right? So, if I replace 3 with a 1, this 3 is a 1, then this thing will break. Oh, sorry, I can't see my screen. If I replace this 3 with a 1 here, this n squared minus n cancels out cleanly, and that will leave you with minus 1. So yeah, it's like I thought. It'll be a very large negative number instead of a very large positive. So you need the 3 to make sure it's positive. Oh frick, there's a typo. We now specialize to the choice x equals c. Alright, so after this I have to do a, like, 3-variable inequality, right? Oh, who puts edit reasons? Do people put edit reasons? This seems like so much work. Alright, oh, right, so I have to take a very long ad break now because people have saved up a lot